This video is designed to end up sharing with you the idea of what is physics. It's just a general background so you know what the scope of the field of physics is really looking like and where it came from. So what is physics? Physics is the study of matter and energy and the relationship with each other. We've talked about these different pieces in courses that you've taken here, but what we want to do is expand upon it. And to illustrate that, I want to do a little bit of a survey with you. Can you name the states of matter? I would hope that you guys got solid, liquid, and gas, but those are just the basis of it. Many of you probably were able to name plasma as another state of matter. And plasma is talking about low pressures and talking about what happens in fluorescent lamps. It also talks about nuclear fusion reactors. But there's actually more than just plasma that adds to this list. A Bose-Einstein condensate might have been something that you learned in your chemistry class. And this is talking about a state of matter that is around the absolute zero. And remember, absolute zero is when the particles inside of anything ends up stop moving. But there's also what's known as a quark gluon plasma. This is what really physicists believe was happening with the start of the universe. And then there's the degenerate matter. And this is talking about what's happening during the course or in the cores of massive stars. So when you look at it, there's actually solid, liquid, gas, plasma, Bose-Einstein condensate, quark gluon, and plasma, and degenerate matter. So there's 7 states of matter that we believe that exist right now. So much like what you have done already in your science and math classes, you know some of the information. And hopefully the intent of this course is to actually allow you to find out more about those topics. So let's start by saying physics is everywhere. It's the basis for all sciences. Physics is what gives us chemistry because the movement of particles and how they're attracted to each other end up giving us chemistry. Chemistry is looking at the reactions of those particles moving back and forth that are built into elements and ions. And then all of those get tied into biology. Many people think biology is the simplest of the science or the easiest of sciences, but that's because we know the most about it in our coursework. But in reality, biology is the most complex of all of them. So where does this all start from? Ancient astronomy, if you've looked at anything with the Egyptians and the Indus Valley civilizations, you know that astronomy was a huge part of their belief systems. Then you started getting into the Greeks, and the Greeks believed that every event had a natural cause, but they were more interested in the idea of thinking. Think Socrates and Plato. Once we got to medieval Europe, they started questioning the great thinkers of the time, like Aristotle. And what they started doing was relying more on observations. That gave birth to 2 schools of physics. The 2 schools of physics are the classical period and the modern physics. Isaac Newton and the laws of motion, James Maxwell, they were on the classical physics side. But then the modern physics are names like Max Planck and Louis de Broglie. Classical physics is actually born in the Renaissance. And what they started doing in the Renaissance period is making changes to the belief systems. And the belief systems were not necessarily based in actual observations. So the Renaissance gave us more solid evidence to show what was actually happening. Then we had the Industrial Revolution, which actually caused the refinement of knowledge. And we had advancements in areas of thermodynamics, chemistry, and electromagnetism. Modern physics is actually helping us to clarify some of the problems that we saw in classical physics. And Maxwell's equation is an example of that. But Albert Einstein did a lot of work, and he's in the area of theory of relativity. And Max Planck was the one who invented quantum theory. So let's take a look at these different topics that exist. On the left, you will see that classical physics is listed in modern physics. We'll go through each one of these. Mechanics is actually what most of you probably think of when it comes to physics. And forces are the key, and the motion of objects are there. And what you have to keep in mind is that there's different terms that are used. Statics is talking about something that's accelerated. Kinematics is motion without regard to what caused it. And the dynamics is the motion and the forces that affect it. And if you go a little bit further into this, you can talk about objects that are solid, so a cube of something or a mass of something, or something that's a fluid dynamics. Fluid dynamics includes air and water because they both act like fluids. Many of us use acoustics every day in our lives, and that's another area of it. We have ultrasounds, we have music. Those are all areas of physics that we use. And if you ever wore a pair of glasses, optics are a big part of your life. But when a physicist looks at optics, they're looking really at visible light, infrared, and ultraviolet radiation. These all act the same. And in your physical science class, you should have learned the terms that are listed there. And what we will do is we will go further and look at some more details in our optics section. Thermodynamics is a fancy word to say heat. And what we know about heat is its energy. So when particles start rubbing next to each other, they increase kinetic energy, and that kinetic energy is measured as heat. So we will talk about thermodynamics. You probably already know the laws of thermodynamics, but we'll look into it even more. Electromagnetism is part of the idea when we look at electromagnetic spectrum. So the whole gamut from gamma rays all the way down to radio waves, and that spectrum will be looked at. Electrostatics is the idea of the charges at rest. Electrodynamics are moving charges, and magnetostatics are the magnetic poles at rest. So the magnetic poles, think of the magnetic north of Earth and how that affects what's going on. And we'll talk about topics that protect us from different pieces there. When we go into the idea of modern physics is talking about elementary particles and particle accelerators. This goes into the idea of what fission and fusion happen, and the knowledge that Albert Einstein established and the dropping of the atomic bombs all tie into this idea of nuclear physics. That's where we have alpha, beta, and gamma decay that you learned about in physical science as well. Quantum physics is looking at the particles and waves in such a in the phenomena that they have, and the energy that comes out of it is referred to quanta. It's trying to tie together all of the fundamental forces. So the four fundamental forces are gravitational force, electromagnetic, weak nuclear, and strong nuclear. And those are listed in order of strength. Gravity, we know the most about, and it helps us understand the mechanics of things. But in reality, the strong nuclear forces play a much bigger role on both small and cosmic scales. So the intent of physics is really quite simple. It's actually trying to do what's known as unification. So the discrepancies between modern and classical physics cannot be rectified right now with the knowledge that we have. So we're trying to tie together universal gravitation and space-time geometry into the idea of general relativity. That's what we have as basis. But that general relativity and the standard model don't necessarily match. And in reality, they should be governed by the same laws. So scientists are working on this. There's pieces that are known as M theory, talking about different dimensions. And in reality, people think there might be 13 dimensions that we just don't know about, instead of the 4 dimensions that we actually live in. So this course in physics is actually just trying to help you understand all of those. And when we study those, we're going to look at the interchange of matter and energy and the relationship that they have with each other.